So we have group number 1 and group number 2. Group number 1 contain these 3 birds that they are purple color. They look very similar, okay? And then group number 2 contain a penguin, okay? It's also a bird. And so what you see is that within group, the birds are very similar. And between group, okay? So these birds and this penguin, they are very different. So this is what we want to achieve in clustering. We want to group the data so that the data point within group, they are very similar. The data point between group, they are very different. Now, the result or the output of the clustering algorithm actually assign, or we call predict, a number to each data point, indicate which cluster a particular data point will belong to. Say for example, okay, we have group number 1. So for the first bird, I will assign number 1 to it. For the second bird, I will assign number 1 to it. For the third bird, we will assign number 1 to it. So it indicates that all these 3 birds, they are belonging to the cluster number 1. And then for the penguin, it is in the cluster number 2, so I assign the value 2 to it. Okay, so that will be the cluster algorithm's result. Each data point, we will assign a number. This number will indicate which cluster it belongs to. Now, in general, clustering technique is a supervised learning technique. Supervised learning technique means that we don't have the response variable y. Okay, so this is called unsupervised learning technique. Supervised learning technique means that we have a response variable y. Say for example, okay, the multiple linear regression we learned in topic 3. It is supervised learning technique because it has response variable y. You will also learn kind of like decision tree or logistic regression or random forest in the higher level course, okay? So whenever those techniques have response variable y, we call it supervised learning. And then for clustering or factor analysis or the other kind of technique, again, where we don't have the response variable y, we call it unsupervised learning. Okay. Now, because for this kind of data set, we don't have the y value to guide us or to supervise us how correct the result will be. So that's why for this unsupervised learning technique, the result will be highly empirical. That means different methods can lead to different groupings, both in number and in content. Because the groups, they are not known a priori, okay? Because we don't know the actual grouping, right? So in that case, it will be difficult to judge whether the result makes sense in the context of the problem being studied. Now, that means that when you are implementing clustering, okay, for the same data set, different objectives will have different clustering results, okay? So that is the kind of technique that requires your judgmental call. I will show you real example in a minute. So let's look at this fake example. We have the cartoon character on the Simpsons cartoon, okay? So let's say we want to group our cartoon character into 2 groups. We have the left-hand side of grouping, okay? We have the Simpsons family group. We have the school engineer employee group, okay? So it makes sense, right? Now, we have another kind of clustering result. We have the female group and the male group. Now, so here we are having 2 different results, okay? Both are reasonable. So that's why we say clustering is subjective, okay? Now, we can also have 3 different groups. We have the kids group, we have the female adult group, we have the male adult group, right? So it also makes sense to you. But which grouping result is better or more suitable for your objective? That depends on the objective, okay, you're looking at. Now, we need to talk about the algorithm before we continue to the application. When we are looking at the K-means algorithm, okay, well, we need to find out whether the data points are close together, okay? Now, recall that one of the objectives in clustering is to find out the data point in a group. They are very close together, okay? So how can we measure how close is the data point in the group? Then we can use distance measure. Distance measure is used to measure how close or how similar of two data points. Okay? Now we have different distance measure. Here we only introduce one of it. It is called Euclidean distance. Euclidean distance is the square root of the sum of the square distance between the coordinate of each variable for two observations. Now, here we take the square root, okay? And then we have two data points, point A and point B. We have the predictor x1, x2 up to xp. So for example, the x1 for point A will be take the value A1, xp take the value AP, okay, for data point A. And for B, the point B, x1 has the value B1, xp has the value BP. Let's look at a simple illustration where p equals to 2. We have two predictors, so this is x1, this is x2. Okay? Now, in that case, x1, x2, x1 equal to 1 for the point A, so this is point A, and so this is the 1, right? x2 equal to 1 for point A. For the point B is here. And we also have the value of x1 and x2. And you can see that x1 take the value 5, so x1 have the value 5, x2 has the value 4. So when we calculate the Euclidean distance, we take the square root of the sum of the square distance, right? So this is the x1 for the point B minus the x1 for point A squared plus the x2 for point B minus the x2 for point A, take the square it, and then the result will be equals to 5. So it tells you that the straight line distance between point A to point B is equals to 5. So basically, Euclidean distance is the straight line distance between 2 points. Okay? Now, we know how to measure how close are two data points. Then we can look at the algorithm for K-means. K-means is very popular hierarchical clustering technique. Non-hierarchical clustering means that we simply split the data into different groups. Okay, we don't have a hierarchical structure. For the hierarchical clustering, okay, that one you will learn in the other course. Okay, it is a kind of hierarchical clustering. We have the hierarchical cluster there. When we implement K-means, we need to specify the number K. Okay, so this K we need to specify it. Let's say we set the K equal to 2 or equal to 10, it's up to you. And then later on, we will tell you how to choose the optimal K, okay, or the K that are your candidate for you to look for. So let's look at the first step. We divide the data into K initial clusters. So this is usually use random the division, okay? And then the number of these clusters may be specified by the user or may be selected by some criterion, okay? Usually they are specified by the user, and later on we will use some criterion to help us to choose a good K. Now, of course, we can also specify the K by some criterion, but that will be out of the scope for this course. Second step, we calculate centroids of each cluster. Centroid is the center of each cluster. Centroid is the center, okay? Now, for K-means, the center of each cluster is the means of the data point, okay, that fall into that specific cluster. So that's why this method is called K-means. And then we continue. For a given data point, we calculate the distance to each center. If the data point is closest to the center of its own cluster, we don't do anything. If the data point is closer to another cluster, then we will assign this data point to another cluster that are closest to it. So this is what we call reassign, okay, the data point. And then next, we will repeat step 3 for each observation. And then we will repeat step 2, 3, 4 until no observations are reassigned. So that is the first impression about the algorithm. So we look at it step by step using a simulation study. Simulation study means that we know where our data are from. So now we know that our data are from 3 groups. We have the blue group, we have the green group, we have the orange, or we call it the red group, okay? So let's see how we can use k-means to group our data into these 3 groups. So let's see, we specify k equal to 3. When we input the data into the algorithm, okay, we don't have any label, so we don't have any color here, right? So this is the raw data. Now for the initialization step, because k equal to 3, we randomly pick 3 data points to be our cluster center. We are using triangle to represent cluster center. And the color is to represent which cluster center it is belonging to. So we have the green cluster center, red cluster center, and the blue cluster center. Okay? And after that, we will look at each data point, calculate the distance of the data point to these 3 cluster center. Okay, so let's choose this data point as an illustration. Okay, now we calculate the distance between this data point to the green center, the distance between this data point to the red center, the distance between this data point to the blue center. Okay, usually, okay, you can already see that the distance between this data point to the red center is the shortest one. So therefore, this data point is closest to the red center. In that case, we will label this data point to fall into the red group. Okay, so we have the red color there. So we will do this procedure, similar procedure for each data point. So say for example, this data point, okay, and it will be closest to the green center than the other center. So this data point, we will assign it to the green group. So each data point, we calculate the distance for the data point to each center, and we will assign the data point to the group that has the shortest distance to the center. Okay, so that's how we do assignment. Okay, here. So after that, we will recalculate each group's center. Now, after we assign the data point, you can see that the green center is here, right? The red center is here, and then the blue center is here. So what we do next is we are using all these green data points, okay? And then we calculate a new center. You can see the new center now moved to here. So how can we calculate the new center? K-means, right? We are taking the average of all the green data points, okay, for the x-axis, and then we have the x-axis for the new green center. For all those green data points, we calculate the average of the vertical axis, and then we have the vertical axis for the new center. Okay, because means, right? Taking average. Now, after you're taking the mean for all those red data points, the red center will move to here, and also the blue center will change, okay, to a different location. So after that, you will reassign the data point again. So how can you reassign? Similar to here, okay, similar to this step. For each data point, we calculate the distance among this data point and each center. Again, we are looking at this data point, okay? So we calculate the distance between this data point to the green center, the distance between this data point to the red center, and the distance between this data point to the blue center. So we find out that the distance of this data point to the green center is the shortest one. That means this data point is the closest to the green group, right? So this point, we will assign it to the green group. So now the color becomes green. Okay. Now, let's say that we are looking at this data point, okay? The distance between this data point to the red center is the shortest one. So we don't need to do anything, okay? Still become red, okay? Still red, okay? We don't need to do anything. For each data point, we will calculate the distance of the data point to each center, and then we will reassign each data point. Okay. Next step, we calculate the cluster center, right? For the green data point, we will calculate the average of the horizontal axis to be the horizontal axis of the new center. The average of the y-axis to be the axis of the new center. Okay, so we do the same for the other data point. You can see that the red center now moved to a lower position. Okay, and it seems that the blue center does not change. Okay, because we don't have any reassignment of the blue data point. So next, we continue to do reassignment. So let's say that we are looking at this data point. Okay. So this is the data point we are talking about. We calculate the distance between this data point to the green center, this data point to the red center, and this data point to the blue center. It turns out that the distance to the green center is the shortest one. So therefore, this data point we will reassign it to the green group. Okay? And after that, we will recompile the new group center. And in the end, we find out that we don't have any new reassignment. So that means that every data point will be closest to the nearest center, okay? So we stop our algorithm. And then this will be our result for the k-means when we set the k equals to 3. Now, let's see what is the impact if we set the k to other value. If we set k equal to 2, okay, for the same data set, now we only have 2 groups. Okay, so originally these 2 groups are separated when k equal to 3, right? Now they combine into 1 group. When we set k equal to 5, we split this group into 2. And we split the top group to be 2 different groups. But that does not make sense, right? So this data point, they obviously are very close together. They should be 4 into the same group. But now we split it when we set the k equal to 5. So that means that in some cases, the k will not give you a good result. Okay? So you may wonder, how can we choose the k then? Because in practice, when you have the data set, you don't know the natural grouping of the data. Okay? You need to find an optimal k. The way for you to do it is to look at the elbow plot. Okay? Elbow plot is a graph where we plot the clustering result corresponding to different number of k. So on this elbow plot, horizontal axis will be the number of cluster k. So we can have 1 cluster, 2 cluster, 3 cluster, up to 10 cluster. So what we do is that we apply the clustering algorithm, like k-means here, for different value of k. So we apply k-means 10 times here. Okay? And then for each k, we calculate the total within cluster sum of square. So how can we calculate the total within cluster sum of square? So this is the general formula. Need to look at the notation first. Cj denote the cluster number j. Okay, we have cluster 1, 2, 3, 4 up to k. If you want to split the data into k group. So Cj indicates the j group. Xi belongs to Cj, means that we are looking at the data point Xi in the cluster number j. And then mu j, it will be the group center of the cluster j. Okay, so mu j is the cluster center. You can imagine that is the triangle, okay, in the previous example. And then xi is the data point, okay, so that is the circle in the previous example. D is the distance measure, okay, and here we are using Euclidean distance. Okay, we only talk about Euclidean distance, so we can use Euclidean distance here. So we calculate the distance between the data point to the corresponding group center, square it, okay, and sum them all up. We do the same thing for each cluster. The result will be called total within squares, within group sum of square. If our clustering result is good, then the distance for the data point to its center should be very small, okay? Because the data points are very close together in the group, right? And in that case, this sum of squares should be small. Now, if the clustering result is very good, for each group, this within cluster sum of square error is good, it's very small, then the resulting total within group sum of square will be very small. Okay, so we will look at the within group sum of square that are not very large, okay, a small one. Now, what we do next is we plot the total within group sum of square and the number of clusters here, okay? So this is the K you specify in the K-means. So what we want to look at is the elbow of the graph. So the elbow of the graph is the location of a band in the plot, okay? Now, we call this elbow plot because it looks like the elbow, okay, of our arm. So this is what we call elbow plot. We look at the elbow. So here, the elbow, this is the elbow, it corresponding to K equals to 3. Okay? So it suggests that K equal to 3 will be a good choice for you. But whether it's good or not, it depends on your interpretation of the clustering result to see whether it satisfies your objective. Now, in the simulation study, we have this elbow plot. Now, I just want to tell you that I will not test you anything on the Python in topic 4. So for clustering, I will not test you anything about Python, okay, in the exam. We only test you about your understanding and the interpretation of the output and some simple calculation. Okay? So now let's look at here. So this is the elbow. It corresponding to K equal to 3. Okay? So it seems that the elbow plot suggests you to group the data into 3 groups. Now, by nature, because this is simulated study, right? We know that our data come from 3 groups. So therefore, the elbow plot suggests a group number, okay, for you. So now let's look at the real application. Okay. Now here we are looking at a finance application. The data is a little bit old, but the kind of idea is very classic, okay? And then we can apply this idea to different kind of financial application. Now, we have the financial performance data from January 1981 issued of Forbes in the magazine, okay? So here is our data table. The first column is the type of the company, okay? You can see that the first 14 company are the chemical company, and then the company 15 to 19, they are the healthcare company. The rest of the company, they are the supermarket company, okay? We call it grocery, okay? The second column is the stock symbol of the corresponding company, okay? And the third column is the company's ID, okay? So for privacy reason here, we do not specify which company they are. So we only use the company ID to indicate that. And the rest of the variable, they are our predictor, okay? They are our predictor. Now, our objective is to group the stock into different categories to help the investor to choose the stock for investment. Objective is very important, okay? Because whether the clustering result is useful or not depends on your objective. It requires your judgmental call, okay? Now, say for example, your investor want to invest in long term, okay? Based on the clustering result, you need to help him or her to choose the correct category. And let's say that your investor is very risk-averse, okay? And you will also look at the clustering result to find out which cluster or which group of the stock is good for this corresponding investor, okay? Now, before we conduct clustering, we need to look at the detail of the variable to understand our data better. Because the variable will tell you the characteristic of each cluster, and then it can help you to name your cluster. Now, we have the PE ratio, and it is the price of one share of the common stock divided by the earning per share for the last year. This ratio shows the dollar amount investors are willing to pay for the stock per dollar of current earning of the company. We have the ROR5. It is the percent rate of return on the total capital average over the past 5 years. So this 5 means the past 5 years. We have the debt to equity ratio for last year. This ratio indicates the extent to which management is using borrowed funds to operate the company. we have the sales growth 5. It is the percent annual compound growth rate of sales computed from the most recent 5 years, compared with the previous 5 years. So this is the 5, okay? And then we have the EPS 5. It is the percent annual compound growth in earning per share. So this earning per share, computed from the most recent 5 years, compared with the previous 5 years. With NPM1, this is the percent net profit margin, okay? Which is the net profit divided by the net sales for the last year, expressed as a percentage. We have the payout 1. It is the annual dividend divided by the last 12 months earning per share. This value represents the proportion of earning payout to the shareholders rather than to the operate and expand the company. Now, so those are the characteristics of a company, okay? So let's look at output, okay? So the first step is to conduct data preprocessing, okay? Now, we actually increase the index of the data frame by 1 in order to make it consistent to the company ID, okay? So this is the company ID. In Python, it always starts from the index 0. So here we increase by 1 so that the index now start from 1, 2, 3, 4 up to 5. Because for some of the algorithm in clustering, they are using the index in the data frame in order to list out the result. We want to directly look at the result to find out which company they are, so we don't want to add by 1. The other thing is to do standardization. So what do we mean by standardization? The predictor xj minus the mean of the predictor divided by the standard deviation of this predictor. Okay, so this is called standardization. Why we need standardization? Okay, well, we say that standardization is actually the usual practice when we are conducting clustering, because we don't want the clustering result to be affected by the unit or by the scale of the predictor. Now, actually in practice, the clustering technique are mostly affected by the variation of the predictor. If the predictor has a large variation compared to another predictor has small variation, then k-means will actually more focus on the predictor that has large variation to group the data. This is not good, okay? Say for example, and let's say that we have the variable income. We can measure income in different units. Income can measure using dollar. Okay, say for example, a person can have the can have the monthly income 20,000 Hong Kong dollar. Okay, now you can imagine that if the income is measured in dollar, the variation of income will be very large. Let's say for the same variable income, okay, and the same data set, okay, we measure income using $1,000. Okay, so for the person who have $30,000 monthly income, now when we measure in $1,000 for the unit, okay, then it becomes 30, right? The value is 30. So for the new variable measured in $1,000, the variation will be much smaller. In that case, when you are performing k-means clustering, okay, if you are measuring income, income will be very useful predictor. They will kind of base on income to separate the data into different groups. But when you measure it using $1,000, because the variation is much smaller, k-means will try to look for the other predictor that has larger variation to separate the data into different groups. Now, standardization is trying to avoid the clustering techniques to have different results that rely on the unit of the predictor and the variation of the predictor. Okay? So the usual step to conduct clustering is to standardize the data. Okay? K-means is a special algorithm for clustering, so that's why we need to conduct standardization. Now, following will be the standardization result. Okay, so the ROR are standardized. It has a mean equal to 0, standard deviation equals to 1. Okay, all those predictors are standardized. Now, let's look at the k-means result. we try to use the elbow plot to find out which K is better for us. For this data set, the K is not as good it's not as easy for us to find. K can be equals to 2 or 3 or even 4. Okay? Because the elbow is not that obvious. What can we do then? Right? Now, that goes back to your objective. You look at the clustering result. For each group, you try to interpret it to see whether the result can satisfy your goal. Now, here, after I look at each group, okay, and for different K, I choose K equal to 3. And let me give you an example. For K equal to 2, okay, K only separate the data into 2 groups, right? One group is the chemical plus supermarket company. The other group is the healthcare company. Now, healthcare company are more profitable than the other type of company. So they only separate the data into healthcare company and the other company. So it does not seem to be very useful for our investor, right? Because we want to help our investor to choose different stock based on the clustering result. Okay? So we abandon that result because it is not very useful to us. What we do is we continue, look at K equal to 3 and also K equal to 4. In the end, K equal to 3 gives us a better result or better interpretation. So why that is the case? So let's look at the following table. So what we do here is that for each cluster, okay, so here we have the cluster number 0, cluster number 1, cluster number 2. Because in Python, the index always starts from 0, okay? So we have 3 groups. For each group, we calculate the average value for a variable. So we have x1, x2, x3, x4, this is not x1, this is x1, x2, x3, x4, x5, x6, x7. Now, observation number, this is the company's ID, okay? So that is not our predictor. And our alpha is the first predictor. In total, we have 7 predictors here. Now we are calculating the mean, that is the average of each predictor in each group. Say for example, we are looking at cluster number 0. For ROR5, this variable, the average is equal to 8.87 in group number 0. ROR5 is equal to 13 point something in group number 1. ROR5 is equal to 9.15 in group number 2. Okay? So what we do is, for each variable, we identify the largest and the smallest value, okay, among the group. So the largest value is 13 point something, that will be related to group number 1. Okay, so this is the cluster number 1. Same thing for DE, okay, we identify that the first value 1.4 something, that is the largest for group number 0. And then for the sales growth 5, group number 0 has the largest value. And then for the EPS 5, group number 1 also has the largest value. NPM also has the largest value for group number 0. PE also has the largest value. Okay, and then for payout, okay, for payout, group number 1 has the largest value. Okay, you can also look at the smallest value to help you to understand the cluster better. Now, let's see. In group 0, it has this kind of characteristic. Group 0 are the company that are high at PE, high at sales growth 5, high at EPS 5, high at NPM 5, high at PE. Okay? Now, next, need to base on your understanding of the field. Okay? If you take some finance course, you have the kind of knowledge to identify this group is actually corresponding to the growth company. For growth company, they have largest sales growth 5 and large PE. Okay, so we can name the cluster number 0 the growth company or the growth stock. And for the second group, it has large value on ROR and large value on payout. Based on your knowledge of the finance field, okay, you know that those companies are corresponding to the income company, okay, or you can call this cluster income stock. And then for the last group, okay, what is the characteristics for it? Now, because you have some idea, right, already, so you kind of look at the value company. It has the lowest PE. You can see that the PE is the lowest, and the payout is also very large. Okay, so that corresponding to the value company. Now, say for example, if your investor want to invest in the long term, you can suggest them to look for the stock in the cluster number 0, the growth company. Okay. If your investor want to invest in short term and they want to trade more frequently, have a high profit, you can suggest them to look at the income company. Okay. And if the investor want to avoid risk, they only have a stable return, but the risk should be very low, then you can suggest them to look at the value company. Okay. Now, in that case, this kind of grouping can satisfy your objective. Because based on different objectives of the investor, you can suggest them to look for the stock that fall into different cluster. So that's why we say that set K equal to 3 is reasonable because it meets your objective. Now, you can also plot the other graph. Okay, so here we are looking at the means for each predictor for each cluster. And you can also look at the standard deviation of the variable for each cluster, but that usually will not be useful, okay? So usually we look at the means. So the first table will be enough. The second one is just 2, okay? And I just show you, you can also look at it. Now, this table is the one that we will show you. If you want to present your result to your boss or to your client, graphical technique is better. But that will be out of the scope, okay? For this course, I only show you, okay, the result. Now, you can see we have a side-by-side box plot, so this is the method 2, to show the clustering result and how to help you to generate the name for each cluster. Now we have the x1, alpha, x2, etc. up to x7. For each predictor, we have a side-by-side box plot. We are using different color to represent different group. So we have the blue color to represent cluster number 0, the orange color to represent cluster number 1, and then the green color to represent cluster number 2. So if you look at x1, okay, so this is the cluster corresponding to variable x1. You can see that the group number 2 has the highest value on R5. Okay, so this is the side-by-side box plot for x2. Then you can see that group number 0 have the largest value, okay, for DE. Okay, you can do this for the other predictor. Now, you will have the same result, okay, as before. So I only copy the cluster name from the previous page to here. Okay, they're the same interpretation. So this is the side-by-side blocks plot. We can also use the radar plot, okay, or some people call it spider map. It depends on which software you are using. So what we look at is the color. Different color represent different cluster. Blue is the cluster number 0, red is the cluster number 1, and then green is the cluster number 2. And then for each distance from the center, it tells you the significance of that variable, that is the importance of that variable to the cluster. So we look at the blue cluster first. We can see that blue cluster has a very large value on sales growth 5, DE, EPS, and PE, okay? And that's why we say that group number 0 is the growth company. Same, okay, same interpretation as the previous page. Just copy, okay, from the previous page. Now, and how about the red group? Red group is cluster number 1. It has large value on R5 and large value on payout, okay? And then for the green group, it has large value on the payout and it has the lowest value on the PE. Okay, so this is the PE. It has the smallest value on PE. Okay, so this is what we call the radar plot or the spider map in order to help you to interpret the result. Now, here is another application. Okay, we are talking about customer segmentation. Customer segmentation is actually very useful in marketing because it can help the marketing department to group the customer into different groups, and for each group they can use different marketing strategy. Now, in the old days, they are using the expertise of the manager, okay, and to group the data into different groups. But nowadays, the marketing department is more data-driven, okay? They are using the clustering algorithm to help them to group the data into different groups because the results are supported by the data. And also, the results are repeatable, adaptable to small changes in the customer structures. So let's look at our real data here. We have a data set that contains 20 customers' information in a mall. And the data contains the variable customer ID, gender, age, annual income, and spending of each customer. Customer ID will not be used as our predictor, okay? And gender, age, annual income, and spending will be our predictor. When we implement k-means, okay, we look at the elbow plot. It seems that k can be equals to 3, or k can be equals to 5, okay? We are looking at the banding, right, of the elbow plot. So which one should we use? After we look at the result, we choose k equals to 5. Why we say it's better? Okay, if you look at the scatter plot between two predictors, I select the predictor annual income and the spending score. Because based on our understanding, these two predictors should be more relevant to the grouping of the more customers. Okay. Now, because we haven't learned some advanced technique to plot several variables in a two-dimensional graph, that's why I choose this tool to show you the result. So different color represent different group. So let's try to name our group. Now, let's look at the purple data first. So this is the purple cluster. It has large value on annual income and small value on the spending. So that means that this group of people, they are rich, but they do not spend a lot, okay? So we can call this group of people the careful people or the careful customer. And then we look at the green group. The green group in the middle, they have average annual income and average spending. So we can call this group of customer the standard customer. And then we have the green group here. The green group have high value on annual income and also high value on spending. So that will be the rich people who spend a lot. Wow, okay, that's good. This is our target customer, okay, our target group. For this group, if you advertise well, they will spend a lot in the mall. Okay, so that's why we can kind of make more advertisement to this group of the customer to increase the profit of the mall. And then we have the yellow group. Yellow group have small value on annual income and large value on spending. Even though this group of people is not very rich, but they like to spend money. So we can call these people careless people, okay? They can spend all their money, right? And you can also target this group in order to let them spend more. Now, we have the red group. The red group are the customer that has low income and low spending. So that will be the poor people who do not want to spend money. We don't want to call them poor people, okay? We call them sensible customer, okay? So this is how you name your customer, or you name our cluster based on your understanding of the field, right? So it makes sense to you, right? In that case, that will be our final cluster. Now, in the end, we say that we introduce what we mean by clustering method. We're trying to group our data into different groups so that the data point within a group will be very close together. The data point among different groups, they are very different. And one algorithm we learned is k-mean. We will use the elbow plot to help us to choose the k. When we calculate whether the data points are close together, we are using Euclidean distance. Okay? Now for the final exam, you only have 1 hour final exam. Okay, don't worry about it, just 1 hour because it is just a 1 credit course. And also, you can bring one piece A4 size, okay, cheat sheet. It has to be handwritten. It has to be handwritten. Okay. Now, if you bring out a printed version, we will collect it. Okay. You won't have cheat sheet anymore. So it has to be handwritten. I don't care whether it's handwritten by you or your boyfriend or girlfriend. Okay. As long as handwritten is okay. Now, and then we will have some formal announcement on Canvas about the exam arrangement. Okay. So the access code for today is 504. 504.